Okay, get ready for this. What if I told you that every movie ever made, every song, every single book, basically all of our digital knowledge could be stored in something that fits right in the palm of your hand? Seriously. And no, this isn't some far-off science fiction. This is the very real future of data storage. But the reason we need it, well, that might just shock you.
To really get why this matters, you have to look at the numbers. Just back in 2017, our global digital universe was already a staggering 16 zettabytes. That's 16 times trillion gigabytes. And since then, that number has been growing exponentially. We are creating data way, way faster than we're creating places to actually put it.
So where does it all go? Well, right now, the answer looks like this. These massive, power-hungry data centers that stretch across thousands and thousands of acres. They're like digital cities, and they consume enormous amounts of energy. We are, and I mean this quite literally, running out of physical space to build them. We're hitting a wall.
But the problem is actually deeper than just real estate. The real issue is a fundamental limitation that's baked right into the technology we rely on. You could say we're caught in the silicon trap.
Think about it like this. Picture a magnificent three-dimensional oak tree in your mind. That's kind of like biological information. It's complex, it's intricate, and data is stored in its very structure. Now, imagine trying to store that entire oak tree in a flat cardboard box. What would you have to do? You'd have to chop it up, flatten it out, and just crush it until it fits, right? You'd destroy its natural form. Well, that is exactly what we do with data. We take this rich, complex information and we force it into the flat, two-dimensional world of ones and zeros. This is the binary bottleneck. We are breaking the natural structure of information just to make it fit. And this is what that looks like in practice. Our silicon-based storage is flat and fragile. It's designed to last a few decades, best case, and it creates this huge mountain of e-waste. But nature's solution? It's complex, it's incredibly resilient, it can last for thousands of years, and it's perfectly sustainable. So it really begs the question, why are we still using the cardboard box when we have the blueprint for the oak tree?
And that, right there, brings us to the solution. A code that wasn't perfected over decades, but over billions of years of evolution. An information storage system so elegant and so powerful that it builds every living thing on Earth. I'm talking, of course, about DNA.
So how does this even work? Well, the concept is actually surprisingly simple. We just need a new alphabet. Instead of 2 letters, 0 and 1, we use the 4 letters of the genetic code, A, C, T, and G. So we take our binary data, we group the bits into pairs, and we assign each pair to a DNA base. So for example, 01 could become C, 10 could become T, and so on. Then a machine synthesizes a physical strand of DNA with that exact sequence. We are literally turning digital bits into biological atoms.
And here is the mind-blowing payoff. How much data can you store this way? A truly staggering 215 petabytes. That's 215 million gigabytes in a single gram of DNA. To put that in perspective, all the data on every server at Google, Facebook, and Microsoft could fit in a teaspoon. Just let that sink in for a second. The entire digital footprint of the world's biggest companies in a teaspoon. If you think sci-fi becoming reality is awesome as I do me a favor and hit that like button. It really helps us make more deep dives just like this one.
Okay, so this isn't just a cool theory. There is a very real race happening right now with tech giants and universities all over the world competing to overcome the challenges and make this tech a practical reality. So let's take a look at the current state of play. And here's the reality check. The potential of DNA, it's undeniable. Its density and longevity are just off the charts. But we have to be honest about the hurdles. Right now, the process is incredibly slow. We're talking hours or even days to write and read data, not nanoseconds. And the cost? Oh boy, it's currently around $400,000 to store a single megabyte. So yeah, we're not quite ready to replace our flash drives just yet.
But the progress is happening fast. Microsoft has already managed to encode and retrieve 200 megabytes of data, including articles and music videos, with 100% accuracy. Researchers at the University of Würzburg are developing these amazing DNA chips using nanocellulose to create sustainable, recyclable hardware. And companies like Twist Bioscience are scaling up the manufacturing of the synthetic DNA we need to fuel this whole revolution. The race is definitely on.
So, with this race underway, what's the ultimate destination? Where does all this progress actually lead? Well, it leads to the creation of a truly permanent, sustainable, and unbelievably dense archive for all of human knowledge. Just imagine an archive that can withstand disaster, that doesn't need a massive power grid, and that could preserve our culture for millennia.
Professor Thomas Dandekar from the University of Würzburg really puts the stakes perfectly. He says we will only last as a civilization if we make the leap into this new type of sustainable computer technology. So this isn't just about better gadgets, it's about the long-term preservation of our entire species' legacy.
Now, this idea, this entire hypothesis we've been exploring, was formulated by Varia. And when you think about a technology on this grand civilizational scale, you have to remember that all revolutionary tech eventually becomes personal. It moves from the lab into our daily lives.
Which brings us to a final and pretty fascinating question. As this technology matures, it's not just going to be for archiving libraries. It's going to be for storing our own personal data, our photos, our journals, our memories. So I have to ask, would you trust your memories to be stored in the code of life itself? Let me know what you think in the comments below. I'm really curious.
If you want to keep exploring the incredible technologies that are shaping our future, make sure to subscribe. And again, the core hypothesis we explored today was formulated by Varia.